Okay, let's continue with the chapter 6.1 lecture. This is part 2. So we're going to continue on with the next part of your note sheets. The next one should be graph discrete probability distributions. And so we talked about probability distributions um, looking like either a graph, a table, or a formula. So here we have the two situations here. Here is a table of values. The variable is the number of the variable X is the number of movies watched on Netflix per month. And the P of X is the probability or the percent of people who watch those number of movies. So P of 2 in this case would represent, so just to remind you, what does P of 2 represent? Well, it equals 0.22, which means 22% of people watch 2 movies on Netflix per month. So that's what that means. And so this is what the graph will look like. It's just a histogram. That's all that is. So the graphical representation of a probability distribution turns out to be a histogram. And so that is the graphical way that we analyze a probability distribution. So you can see one movie is the most amount that people watch per month. And so that's what it looks like. So you would just put that information in, and then you would make a histogram of that. And so that's what the graph of a probability distribution looks like. An important question that comes up is calculating the mean or expected value. That becomes an important question to be able to do. And so, for example, if you randomly picked one person who has Netflix, how many movies would we expect them to download per month? And so in this case, you can see we might guess 1 because that's the highest percentages, but what would we expect? 1, but we can actually find what's called the mean or the expected value of a discrete random variable like this here. And so there's a formula, and you've actually seen it before, but the formula we use, the formula for to calculate the mean of a random discrete random variable will be, oops, let me get back you some space here. There we go. And so here's the formula. I'm going to show you how to do it on StatCrunch also. So keep in mind StatCrunch will also be used. But the expected value or the mean, remember this is it's not a sample right now. So that's why we're not using X bar. The mean or mu, the mu of the random variable X is going to be equal to the sum of the value of X times the probability of it, and add those up together, and that would be your mean, or what we would call later on in the next example, we call it the expected value. And so to calculate that would be pretty easy on this example here. It would just be 0 times 0.06 plus 1 times 0.58. Let me use parentheses instead. Plus 2 times 0.22 plus 3 times 0.10. And we'll finish this off. And so then you would do that calculation, and what you get there would be what the mean number of movies people download. To get that value, you use your calculator course. I also want to show you on StatCrunch how to do that. Let me bring in StatCrunch real quick. And so on StatCrunch, I entered the values. So you can see those are the values right there. 0, 1, 2, 3, 4, 5, and then the probabilities are there. And so I entered those values in. And so to do that, we're going to do summary stats. Hold on, let's do this again. So let's finish this up again. So not in stat, but what we want is calculators, not summary stats. And in this case, this is going to be a special calculator. It's called a custom calculator. The values are in variable X. So we went again, let's show you one more time. Stat calculators. These are for the probability distributions, finding the mean or expected values. Calculators, custom calculator. Variables are in X, weights are in P of X, and this is very similar to finding your grade point average kind of relationship or group data. And then just compute. And so in this case right here would be the mean of that. So we would expect people to watch 1.49 movies. Here's a standard deviation, which we're going to get in the next section, but we'd get it the same way. And so that's the value we would have for this result here. This would be equal to 1.49 movies if you add that up. And so I use StatCrunch to get that calculation for us. And so now we can have the mean or expected value. And so that becomes what we call the interpretation of it. The mean of a discrete random variable, we call many times we say it's expected value. What would we expect if one person how many movies would we expect a person who watches Netflix to download? We would say 1.49. And so in this case here, that leaves us with the interpretation of that. And so here's a note here to keep in mind. Because of the mean of a random variable represents what we would expect to happen in the long run, it is also called the expected value, and we would use E of X. The interpretation of the expected value is the same as the interpretation of the mean of a discrete random variable. We just use the term expected value. And so here's one more example to take a look at. Example 4, go ahead and read that real fast. Okay, now that you read it, let's set the situation. Let's take a look at the approach we'll take to solve this problem. And so looking at this here, it's a situation where insurance companies have to decide how much to sell insurance policies for, because in the end they're in the business to make money. So here's the scenario that's being set up. Let's make a table. We have some outcomes. And in this case, the outcome of these situations and the probability of those outcomes. Here's the situation. If you buy a life insurance policy, you're either going to survive the year or you're not. And so in the case that you survive, you basically end up having to pay, the insurance company ends up making $350 on you, because that's what you're paying. Oh, sorry, not 350. Let's fix that real quick. I have it backwards. The probability, it would be 530. And the other outcome that happens is that you don't survive, that you die within the year. And so what happens is if you die within that year, the insurance company loses money. They end up having to pay you $250,000, but they already collected 530 from you. So technically what's going to happen is they lose $249,470. And so that's what happens. Where do I get that number again? I just did 250,000. This is what the insurance company is going to lose, but they ended up getting your 530. So they end up losing 249,470. And so how often do you survive? Well, we have the data. You survive 0.99791% of the time, which then means that you die 0.00 to 0.00209% of the time. And so there's our setup. And so compute the expected value of this policy to the insurance company. And so the expected value for this policy is going to be, they make $530, 0.99791% of the time, and then they lose $249,470. They lose that 0.0029% of the time. And so that calculation would be what the insurance company ends up making for each of those policies. And so we'll do that by calculator. We're also going to show you how to, I'm going to remind you how to do that by on StatCrunch. And so in this case, it was 470 there. The other number was 530. I'm just getting the values from my table. Those were the probabilities, and then we go ahead and, oops, I have it backwards here. This should be 530 negative 249 470. That's what the insurance company makes on you. 99.791% of the time, and then 0.00209% of the time they have to pay out for people who pass away. So we just go ahead, stat calculators again, custom. My variables are in the outcome, weights in the probability outcome, and then you compute. And so in this case here, it looks like the expected value is 7.5, which then means that, there's our value 7.5, which then means that the insurance company makes $7.50 per policy.